Ever wondered why minerals have so many funny colors? Well, me too, and I figured it out. The color that comes off from rocks can be explained by the crystal field theory. The crystal field theory originated as a method to explain why metals have such beautiful colors and unique magnetic properties. First devised by Hans Bethe and Johannes Hasbrouck van Willek in the 1930s, it postulates at the simplest level that d orbitals utilized by transition metals for binding is split into two portions. The energy difference and the spatial positioning leads to unique magnetic properties and also unique colorations of the rock. Okay, let's ask the why first. So firstly, all transition metals have a d shell and they bond with that d shell. When a transition metal binds with ligands, some of the electrons of the transition metal are repulsed by electron-electron repulsions that occur between the transition metal and the ligand. This repulsion blocks off some of the d shell orbitals from bonding, and therefore that causes some d orbitals to actually bond with the ligand and some to stay behind with the atom. This leaves an energy difference between d shell conducting the bonding and the d shells which remain behind, which is represented by delta O. This introduces unique magnetic properties / electron movements, as the upper layer conducting the bonding is paramagnetic and the lower layer is diamagnetic. Paramagnetic means that some electrons are unpaired. This allows for the electron to be influenced by outside forces such as a magnet, and why some minerals exhibit magnetic properties. Now, in terms of how this explains mineral color, let's explain why certain molecules have certain colorations. So when electrons absorb photons, they absorb only the photons at the right wavelength to get them up to a particular shell level. The photons which aren't absorbed are reflected back as the color that we see. Now let's apply this to crystal field theory. So when d shells split, the energy between the upper, more energetic layer is represented with delta O. Electrons, when hit with a photon, will absorb the exact photon with enough energy to bring them from the lower d shell to the upper d shell. Thus, when photons carrying the exact energy do this, it will be absorbed by the electron and it will go up to the upper layer. This means that any photons not absorbed are reflected back, which is why you see a specific color for the mineral. Also, on another note, due to the heat within the system, this causes atoms to move around. This means that the metal ligand electron-electron repulsions vary from time to time, meaning that the light absorption and the color given off is more of a smear on the color spectrum, as the d shell energy difference is constantly in flux.